Good afternoon, everyone. Thank you for attending our standard versus custom battery packs Decoding the Power Play webinar. My name is Ryan Wood, Content Marketing Manager here at Epic. Before we get started, I just want to let you all know that you'll be muted during the presentation. If you have any questions as we move along, please enter them into the questions panel, which is located in the webinar control panel, and we'll try to get to them all at the end of this presentation. If we don't have time to go through all your questions, we will be sure to reply back to you by email. Also, we will be recording this webinar and we'll be posting both the recording and the slides on our website and YouTube channel. Our presenter today is Anton Beck, our battery product manager. Anton came to Epic with over 25 years of electronics manufacturing experience. His background includes all manufacturing processes from design to fabrication. Anton is consistently focused on developing our battery design and manufacturing infrastructure to continually improve our value-added supply chain organization. Anton's responsibilities include overseeing our design team, product prototype development, tooling and test processes, regulatory approval management, and subcomponent supply chain to ensure Epic's world-class standards to our customers are maintained. Anton oversees hundreds of custom battery pack design projects. He has extensive experience with medical devices, UL, CE, UNDOT, and military power electronics applications. So without further ado, I will pass it on over to Anton.
Thanks, Ryan. And good afternoon, everyone, and welcome to the webinar. And today our agenda is around helping everybody understand what the difference is in between standard versus custom battery packs. Because even in the name itself, it's kind of deceiving as to what it means. And we want to put some definition behind each one of them to help our customers and help electronic designers determine what's the best course of action to use when they're determining their battery pack requirements. So there's the agenda for today's webinar. And in the first bullet point, that's really the goal of the entire presentation. We really want to give you, from a high level, what the differences are between the two. Some of the definitions, some of the real specific things that make these packs what we call standard packs versus custom packs. Because as we get further into this presentation and into some of the definitions and specifics, you're going to really see what the differences are between the two and why we consider standard versus custom. But overall, all this will be gone into pretty in depth in this presentation. So we're going to start at a 10,000 foot high level, what the difference is between the two, standard versus custom. So let's start with why we're having this discussion. Well, the biggest reason is because that old saying, you can have everything you want, anything you want, you just can't have everything you want. And really, that's what we find in applications like this in our battery packs. Really understanding the application of what your needs are is going to help you get to the right solution a whole lot faster. Because again, when you build a custom battery pack with all the specific and higher level technologies that are associated with it, they all have an associated cost too. Not only the cost of the product, but the cost of the time in the development. So we want to make sure that everybody understands that while we have endless possibilities, that doesn't mean they belong in every battery pack. And that real goal here today is to help our customers really understand and be able to determine what they need and what they don't need based on their specific application. Sorry. So why choose custom over standard? And this goes back to the last slide, the needs versus wants, and we're going to go through a couple of these things here. There isn't all of them, but this is a couple of the reasons we're going to talk about in unit cost. We talked in the last slide, the fact that more specifications, the more requirements, the more features, the higher the cost level. So really understanding what your unit cost is, and typically when we're working with companies, by the time they come to us for a design, they pretty much understand what they've allocated for a cost. And that's really good for people like us to know when we're starting this, because you can direct them down the right path when it comes to what you want and what you want for a cost. Because that's really important to understand up front. Some of the operational requirements, if you're looking at, for an example, lithium battery packs, most of them have a 500 life cycle, so the battery pack can charge and discharge 500 times. Well, if you're looking to do that once a day, that really means it has to be controlled a lot more precisely than if you're going to do it once a week. If you're only doing it once a week, you can have something that's very simple. And once a week, that's going to last you maybe 4 to 5 years in terms of life cycles. But if you need to charge it once a day, you really need to understand and manage the BMS and to be able to ensure that you're not overcharging and over discharging and reducing the life cycles. The other thing is around application specifics. There's direct safety requirements depending on what the application is. Something like a hunting decoy has a much different level of safety requirements than a wearable medical device, and that goes along with regulatory specifications as well. An example being UN 38.3 that's required for each individual custom battery design so that we can ship air. And that's usually a very simple certification with almost all the lithium battery packs we do. We'll make sure it passes that, but requiring a higher level of safety, such as a nail propagation test, for example, if you're working on an electric vehicle, you may be required to pass a nail propagation test, and that requires some very custom software, firmware, different components to be used. So you can see there's a whole lot of difference between a custom and a standard. And what our goal here today is to really help identify and help you identify what you're going to need to go forward. Some of the critical things that you're going to need to understand as we're making your decision. The first thing is, everybody's heard of this before, the battery management system, or the BMS. And the BMS, in its very simplest terms, really ensures that the safe and efficient operation of the battery pack. Everybody's seen all the crazy pictures with lithium batteries catching on fire, which is a thermal runaway condition. And that's really what the most important function of the BMS is. Now, it's got a lot of additional functions as well. And how many functions that you want us to perform is going to determine whether you're talking about a standard or a custom pack. And you can see there's a couple of functions we'll talk about as we get further into this. Battery cycle life. One of the things that everybody sometimes forgets is that lithium batteries don't have unlimited number of life cycles. Usually the batteries are rated for 500 cycles before they start to lose their capacity. So basically we can help you extend that by changing how deep we're going to discharge and charge, discharge, what are the charging discharge rates, how we manage the temperature, and how we stop charging or discharging if we get to a certain level. But those are things that we can help you do. But again, that's a very custom design versus something that's a very standard design, which may only have temperature control. Battery capacity. And one of the things around that you need to be aware of in the early stage of the design is what size battery you need. And there's a couple of reasons for this, because the smaller the battery, the more standard options we have. The larger the battery would be less. And the larger the battery gets, the more complex all of those BMS features become. And they're just not a whole lot of standard features when you get into something that you're looking at, let's say 16 amps versus something that goes up to 100 amps. That's a big difference in what we have to do to manufacture and design that product for our customers. And why are all those things important that we just talked about? Well, first of all, every single one of these is going to directly affect the cost of the battery pack, and for a couple of reasons. Because you're going to go through all these very complex functions to the battery and create a larger printed circuit board, more additional and costly IC components, and it also impacts the amount of design time. Because if you've got a situation where the battery you see down at the bottom of this, it's got 36 cells. That's 4 different zones, and that's a lot. Basically, there's 4 different BMSs on that printed circuit board there. So as you can imagine, the more the features, the higher the cost, and the longer the development time. And that's why all these things are important. And the more features you want to put on it, the less options we have to stand for a standard pack that we can move quickly on. So let's talk about what a standard pack looks like. We talk about predetermined specifications and features like their limited fit sizes, capacities, voltages. And if you've got like a 2S4P pack and you want it to be Very simple. We could do that very easily. And we've got probably 4 or 5 different standard BMS options we can use and change them a little bit to get you exactly what you're looking for. But they're limited, and they're very limited in what we can add. So what are the benefits of doing a standard pack? This is a nickel metal hydride pack up there on the screen, but that's a pretty simple pack. And nickel metal hydride, believe it or not, does have an electronic cell control in there just as well. It's not as in depth as a lithium, but they have one either way. So let's talk about what some of the benefits are and some of the limitations. Well, what's in the battery pack? A standard battery pack isn't something that's off the shelf. We don't have 500 different configurations of finished battery packs sitting on a shelf for you to just say you'd like to try one and we ship it to you. That's not what we do. There still requires some design work. The reality is we're going to be in a better position where we can move quickly to change the profile depending upon the cell type we want and depending on the manufacturer. We just have to get ahead and do some programming. But it's very simple because the majority of these designs already exist somewhere. We also don't have UL or UN on these batteries, so you'll have to go through that, UN or UL if that's what you want. Now, obviously, if it's a smaller pack like a 1S4P, that's a standard pack, that's going to go through pretty quickly. Now, some distributors do have smaller packs available, like that little black one you see on the bottom, that's an alkaline 4-cell pack. You can get those off of DigiKey, off the shelf, but they've also got nickel metal hydride packs. They've even got some lithium, but you're going to get a lithium pack from a distributor. You're going to get it off the shelf out of the box, and you can't customize it any way that you want. Where with our standard packs, we do some customization work. So again, it's not an off-the-shelf type product. It's because even we move faster on customizing these standard packs, they're very generic. We already have the predetermined charge and discharge parameters, the generic safety features, which are the overcharge and over discharge protection, already built in. We just go ahead and adjust them. We basically say, here's the cell that we're going to use, here's the manufacturer, here's the profile, and we go ahead and we program the BMS to manage that particular cell. We have very limited diagnostic capabilities, so you're not going to be in a situation like this where we're tracking all the parameters and keeping track of it so you can plug it in somewhere later, pull up the information, see how your battery did. That's not happening in the standard pack. In a custom pack, we have that capability exists. We can build that for whatever you need. Temperature monitoring the standard battery packs is simple. You're usually going to have a thermistor somewhere, some other type of temperature sensor, or maybe both. Then you're going to read the temperature that's coming in through how you're going to charge on your printed circuit board, where it's not going to be going through a huge amount of monitoring and temperature using our controls on the BMS or charge or discharge the temperature model. This is mostly going to be a threshold base where it's like a certain level where we're going to shut it off. That's traditionally what a standard pack does. Now with a custom pack, we can do a lot more, and we'll talk about that as we get a little further. The biggest benefit of is the reduced time and lower unit costs, but you're giving up certain functionalities that you can't customize. And the biggest thing we've got to take away from this is that you still need to go back through certifications if that's what you want. Now it's not as long as the development cost, and we'll get into the certification part of this a little bit faster, or I'm sorry, a little bit further in the presentation. So now let's get into some custom battery pack, what it really is, because as you can see from something like this, that's a very custom pack. It has substantial amount of technology in it, and we're going to go through a lot about this here as we move forward. So when I look at a custom battery pack, I really think about 3 specific things. It's got a tailored design, which means we start with a blank piece of paper. The blank piece of paper is basically going to take what you're looking for as a customer in terms of capacity, voltages, how long you want it to last, and what you want it to communicate to, and other performance characteristics that we're going to build this thing from the ground up. That means it's highly customizable. That means because we design the software and firmware, we're going to tell it exactly what to do. We're not taking anything off the shelf and tweak it a little bit. We're going to design everything so that it's a specific set of parameters. And why would you want both of those things? Specifically because you want to have the best possible performance in your application, which means efficiency, lifespan, and power delivery. Those are three things that we can really affect by designing a custom battery pack, and so especially with the portable devices. That is what a custom battery packs a lot of times is used for. The standard ones are more for backup battery type of applications because it's not as critical. It's used as a backup to optimize the performance, and that's why we get into very custom battery packs. So what are the features? Obviously, as we talked about, it's designed according to your form factor specification, and it's fine-tuned. There are many different parameters that we can fine-tune and we can control, and that we work with the customer on as to get into the application, because everybody's application is different. You think that this thing's going to happen, one thing's going to happen when you turn this thing on, and when we design the prototype and we find out a lot of different things are happening. And we can tweak the design based upon that. And the reason we understand what's happening is because we can put in high-end monitoring into these battery packs so we can record all the data when it's happening. But as you can imagine, and you know, everything costs money to be able to do that. And then even in some instances, we can create remote access and control. There's a lot of ways you can help, we can get you in the design depending on what you're trying to do, but it also allows your device to be controlled very precisely. So when we talk about the BMS on the standard pack, it was simple. We talked about temperature, fixed charge, and discharge, and that was really the amount of what we're managing here, but not in a custom pack. Doing internal cell balancing, fault diagnostics, charge and discharge profiles that are not only tailored, but they're inside tight tolerances that can be very specific. We can really fine tune. I think there's anywhere between 10 and 20 different parameters that we can monitor, log, and adjust in the pack to not only work for your application, but as it ages a little bit, it helps it last longer and actually manages your device better over time. These are the different parameters that we can monitor. These are probably the biggest, and temperature is the one, like we talked about in the standard size. It's a little bit different because we can monitor and adjust in a custom pack. In the standard pack, we can basically monitor and shut off. That's really what it does. But if you look at things like cell balancing, we're not really cell balancing in a standard pack. It is what it is when it gets plugged in. That's the way it's going to be until the battery basically dies. Not here, because when we can balance and monitor the cells and change how we're charging and discharging accordingly, things like state of charge to help with utilization, state of health, so that you can understand the remaining lifespan of the battery, and so that you know well in advance of the battery losing its capacity and what's about to happen. There's a lot of different parameters we can monitor and adjust as well. And these parameters allow us to adjust, manage the battery over time, and that helps you help your customer, and it gives us the ability to give your application optimal performance based upon its power management. Right, so we've talked about this already, but really the four real advantages, and the big one is the enhanced safety, because we're monitoring this so many different things. We've got many different tricks of the trade we can put into the circuitry and into the software to allow us to be able to monitor, and especially things like thermal runaway. In many of our designs, we not only have software, but firmware safety, and along with that, several mechanical safeties as well. So we have several different backups that allow us 3 or 4 different levels of safety, so we can minimize things like thermal runaway. Now you can imagine that's costly, right? Where the ones you've seen on TV that caught on fire, they don't have that because they're probably less expensive models. and you're not going to put 4 different safety mechanisms in something that is a really cost-effective device. So when you look at why we monitor temperature as strictly as we do in custom packs, we talked about the safety, and that is probably the one everybody knows about, but it's not just that. Because if you look at how we can optimize the performance, the profiling and the temperature allows us to create the most optimal charge and discharge rates. So the battery life cycle can be maximized. So we're going to monitor that, and we're going to change and charge and discharge when it's best for the battery to do so. And that's why we're able to extend the lifespan by minimizing the stress on the cells themselves. And then there are certain regulatory issues. Again, if it's a wearable and it gets warm, you're going to want to have a lot of safeties in that to be able to monitor and turn it off. You know, everybody's got the example of their iPhone in their hand when it gets really hot. You've probably seen on some of the phones where it tells you the battery's too hot and turning off. Well, that's enhanced temperature monitoring looks like. The biggest challenge with custom battery packs is the time it takes, because really, if you've got to program everything from the ground up, it's going to take you a little bit more time. Not only time to create all the software and firmware, but you've got to create all the printed circuit boards, the circuitry, and then you've got to test it. You've got to test it on a bench, make sure that it does exactly what you want it to do before you give it to the customer, who then is going to start a trial and error, excuse me, in their application. And the reality is, there's never been a time that the prototypes have worked great first time out of the gate. That's why the customer application needs to test it and go and what's going to happen to see what's actually working in the device under different stresses and different environments. So that's why it takes long to do that. And there's significant development costs, because we're not taking a standard or catalog BMS and changing a few parameters and attaching it to some cells. We're starting from scratch. So why the difference in time? Like we said, like we talked about, with a standard pack, we're usually taking a catalog model BMS and we're changing the programming. We're adding the profile of the cells, and they've got commonly used cells and models that are available. So if you're talking about an 18650 from Samsung, we've got that profile, and so does everybody else. So this is usually very quick, where a custom BMS needs to be designed. All the programming, and not only the programming, like I said, the boards, all the test programs, the programming fixtures, all the test fixtures are all developed from scratch. We have to develop them as part of what we do, and that's usually also other custom parts, whether it's custom connectors, whether it's an enclosure, whether it's plastic or steel, or how we're going to encapsulate that particular battery in the enclosure. All that's custom, and that's why it takes time, where a standard can be done relatively quickly. So the last part about this, we're going to talk about the specific timelines and what the certifications are for custom battery packs. The development timeline for a standard pack could be as little as 4 weeks. We can have your prototypes because we have everything we need. We just have to take all the pieces and put them together. Where a custom battery pack, just to design it, could take up to 8 to 12 weeks, if not longer, and then another 6 weeks for the prototypes before we're looking to start. We're going to do a design. It takes a lot of time. We have to start with an IC based upon what the customer wants to use. And sometimes we find out that doesn't work and we've got to change it out. And then we've got to order all the parts. We've got to get the printed circuit boards assembled again. And so we've got to put everything together. Now, the prototypes can be 4 to 6 weeks. You're talking about some really rudimentary PCBAs, and a lot of times it's SLS printed enclosures, but we've got something to put in front of the customer. But if it takes time to do this, because again, we're not just, as we're doing the standard, we're taking a bunch of things that are already existing and tweaking them to meet what you may want. For regulatory timelines, you know, traditionally that one on the right is the one that everybody has to get, right? the 38.3, because all lithium has to pass 38.3. Otherwise, you have to ship all lithium packs ground, and you can't ship air. And that's just not something that's feasible in most applications. So it takes an additional 16 packs to manufacture. It costs anywhere from $5,000 to $7,000, and they'll use those 16 packs and they'll do test. It takes anywhere from 4 to 6 weeks, and then you've got other specific certifications there. The UL is obviously the most critical in terms of the amount of packs it takes and the amount of time and cost. And depending on what UL standards you're testing to, we have to know that up front, because we have to design everything in order to meet that specification, which also adds time to the design. Because we know there's certain requirements, especially around safety, so that the IEC and CE are sometimes needed. IEC more than others, but those certifications can be done laterally only after the 38.3 cert is completed and the design is locked down. So how to minimize your development time? The best thing you can do is to start talking to a battery pack manufacturer early in the design before you get too far down the road, especially because if you decide you want a certain management IC or you want a certain cell, because you can back yourself into a corner really fast if you pick something like a 50-week lead time from TI IC or a cell that's just not readily available. And that's why you want to talk to your battery folks early, all right? The second thing you want to understand is that you can have anything you want, you just can't have everything. We can build a pack with every single bell and whistle on it that you want, but your application, can it afford it? And that's the number one thing, right? The question can be is going with the design parameter, excuse me. Okay, so can your battery pack do this? Yes. What is going to cost? That should be the next question out of everybody's mouth, because in the discussion, how much additional cost is going to make on your battery pack in production? Because that's really what you care about. You care about if you're talking about something that you can add to it, but it's going to double the cost of the pack, and it's just not feasible. So in summary, the biggest key difference and the biggest takeaways of the standard are very quick and cost effective, and we can move quickly to get you something that's cost effective and fast. That's really what it boils down to. Custom packs are very specific and they're highly specialized, and they basically provide you with the most optimal performance. What are your considerations for picking the two? Obviously, cost is number one. The more you can stay around standard, the lower your cost is going to be. Time, most folks come to us without the real understanding of how long it's going to take to develop and go through certifications. But you saw from the previous slides, UL is 15 to 20 weeks. Well, we're not going to go into UL until the customer does all their testing and we finalize the design. And many times that can be up to a year from the time we start. And the number one takeaway is to talk to your battery manufacturer early so that you can balance everything and that you're getting exactly what your application can afford and in the time that you need it to be ready.
Thank you, Anton. While Anton reviews the questions that came in, I just want to briefly mention some of the additional PCB-based products we offer here at Epic. Printed circuit boards, flex and rigid flex PCBs, cable assemblies, CNC machining, high reliability user interfaces, flexible heaters, and our energy efficient fans and motors. And now I'll turn it on back over to Anton to go through some of the questions that came in.
Okay, let me look here. Here's one. Is the 4-week lead time for standard battery packs the delivery timing? Well, no, that is typically a manufacturing time that it takes us to build the packs. We have to account for shipping, and then the UN 38.3, until the UN 38.3 is in place, it will be ground shipment, most likely class 9. So for the lithium, that's our manufacturing time. Let me see. What type of wire harnesses and connectors are available for the standard option batteries? Well, we have many options, and that's kind of determined up front with a customer discussion before we even start. So we do have options. We just have to dial it in at the beginning of the program. Let's see. If I order standard battery packs, why would I need a prototype? That's a good one. Well, keep in mind the standard packs BMS is slightly customized for parameters that we discussed prior to producing to support your application. You need time to do the testing in your device and confirm it meets form, fit, and function before we get into production. Even if it's not lithium pack, you still want prototypes. They're highly recommended to ensure that it's form, fit, and function. Let me see what else. You mentioned enclosures for custom battery packs. Can you design? And our answer is yes, we can design, and that's typically part of the design process. So we can collaborate with the customer for internal features on the enclosure that support the battery and pass all regulatory, and the battery doesn't get too hot, and etc. So yes, that's part of our process. And let me see. Are you able to design with fuel gauging options? Yes, that's typically driven by the customer as well. But if not, we have multiple options, and we'll select something based on the application and the functionality that the customer needs. And that's about all the time we have. So we'll continue to take on your questions via email, and we'll provide answers and responses as quickly as possible. And I want to thank everybody for attending, and I hope you found it beneficial. Thank you.